Okay, good morning. Welcome to
FunMath172.
FunMath number 172. So today we're not in art of problem solving because you asked me a really interesting question about Lego sets. Okay? So we did it. We had a really fun day, right?
Mm-hmm.
Okay, so here's the question you asked me. The new Lego figures come in 10 sets of 16 figures. Okay? Mm-hmm. If you had all 160 figures spread out randomly on a table and then picked 16 at random, okay? So show the Lego figures. Now this is just
Part of them.
part of them, and these aren't even the new ones, right?
No.
This is just some stuff we got from upstairs. So you had all 160 spread out on a table, and then picked 16 at random. What's the probability that you picked 16 from one of the 10 sets? So you got super lucky.
Yeah.
Okay.
Yeah.
So let's just kind of summarize what we did, because this took about an hour to work through, but it was really cool, right?
Yeah.
Okay. So the first thing, step one was, what does probability mean? It means the number of, we'll call it good cases, over the number of total cases. Okay, and so the number of good cases was what?
It was 10.
Okay, why is the number of good cases 10?
Because there's 10 sets.
There's 10 different sets. So the number of good cases for your set of 16 that you picked was 10. And then the question was, how many sets of 16 are there? How many? You can put the Legos down if you want. Okay. So this was what you figured out right away. Okay?
Yeah.
There's 10 ones that work, 10 sets of 16 that work, and then all we have to do is figure out how many different sets of 16 are there that you can pick from 160.
There's
So
a lot.
that shouldn't be too hard, right?
No.
No. So we decided to make an easier problem first, right?
Mm-hmm.
And we looked at, do you remember what we looked at first?
We looked at 4 minifigures.
We looked at sets of 4. So we'll do 1, 2, 3, 4. So I won't draw the minifigures. But we said, how many ways can you pick 2 from 4? Okay. And what do you do? How do you figure this out?
Well, there's 4 choices for the first minifigure and 3 choices for the second.
4 choices for the first minifigure, 3 choices for the second. Here, let's show them to the screen. Okay. So if we started with 4, we might pick those 2. I've got 4 ways to pick the first one. And once I pick the first one, I've got 3 left. Now, so are there 12 ways to pick 2 from 4?
No.
Why not?
Because we double counted each of them.
Okay, so show why. Get your 2 minifigures.
Because if we pick this one first and this one second, it's the same as picking this one first and this one second.
Aha, so we actually had to divide by 2. So there were actually 12 divided by 2, which is 6. There's 6 ways to pick 4 from 2. And now, pick 2 from 4.
Yeah.
Then we said pick 3 from 4. Okay, so this was the same idea. And we did 4, we had 4 choices for the first, 3 choices for the second, 2 choices for the third, but now we felt like we were way overcounting because this was 12 times 2, which was 24.
Well, because picking this one first, this one second, this one third is the same as picking this one first, this one second, and this one third.
Okay, and so we found out we had to divide by 3 times 2 times 1. 3 choices for the first guy in our set of 3, 2 choices for the second guy, and then 1 for the third. And this also, by coincidence, happened to be 6. It's 12 times 2, 24, divided by 6. Okay. And then we found that this related to something really cool called Pascal's triangle.
Yeah.
But that's a different movie for a different day. But we spent a lot of time talking about Pascal's triangle, right?
Yeah.
But then we said pick 16 from 160 must be the same idea. We have 160 choices for the first, 159 choices for the second, 158 choices for the third, all the way down to, for the 16th, we're going to have 145 choices. But we now, in our groups of 16, we overcount them because there's 16 ways to pick the first, 15, 14, all the way down to 2 times 1. Now this is going to be a big number, right?
Yeah.
So, did we do this in our heads?
No, I don't think so.
We asked our good friend
Mathematica.
to do this, and this worked out to be 4 sextillion, 59 quintillion, 949 quadrillion, 873 trillion, 964 billion, 357 million, 469,950.
And this is 10 over this.
And so remember, we needed, for our answer to our problem, we needed 10 divided by this.
But we could just take off the end 0.
We could take off the end 0, and we'd be left with...
400 quintillion.
Let me move the commas when I take off the 0. So, comma, comma. I didn't think this through too well. There we go. 405 quintillion. 1 divided by 405 quintillion.
That's a lot of minifigures.
Right, so if we had all 160 minifigures on the table spread out randomly, and like I put a blindfold on you and you pick them at random, you would have to pick roughly 400 quintillion times before you got 16 from the same set. Whoa.
Maybe you'll get lucky.
Yeah, you might get lucky and do it sooner than that, but on average, that's how long it would take you. 400. Now, do we have time to pick 400 quintillion times?
Probably not.
Probably not. So we better not get any of these Legos because this is too complicated. Right?
Yeah.
Okay. Hey, that was an awesome question. I'm glad you asked that. That was a really fun morning.